In this video, we're going to go over how to find horizontal and oblique or slant asymptotes. And so to be able to find horizontal or oblique asymptotes, we're going to compare the degree of the numerator, which we will call n, with the degree of the numerator, which we will call m. So when we compare these, there are four different things or four different cases that could happen. So case one, if the degree in the numerator is equal to the degree in the numerator, then the horizontal asymptote is the ratio of the leading coefficients. And so if we go with those n and m's, those are going to be equal to each other. So in my example, I have 9x squared plus, it doesn't matter what else is plus here, so that's why I didn't type anything in, over 3x squared plus, again, it doesn't matter because what we care about is those leading coefficients and those degrees. So here, because my degree is even, okay, and this is technically m, and this is m down here, because those are the same, then what I do is I take these leading coefficients here, and that becomes my horizontal asymptote. So I would have y equals 9 over 3, which is 3. So my horizontal asymptote is y equals 3. So when I graph that, I would come up to positive 3. My horizontal asymptote will go through that. Okay, so when they're equal, you take the ratio of the leading coefficients, and that's your vertical asymptote. Case 2, if the degree in the numerator is less than the degree in the denominator, then the horizontal asymptote is y equals 0. So in this example here, my n is 5, my m is 9. Because 5 is less than 9, it is just simply y equals 0. And I feel like that should kind of make sense. If you keep putting bigger and bigger numbers in here, okay, so if you put 1 over 1, 2 over 2, 3 over 3, this 9 is going to make the denominator so much bigger, so much quicker, that you're going to end up with a much smaller number over a much larger number. And so that fraction is just going to keep getting smaller and smaller and smaller until it's eventually so close to 0. Okay, and when you graph that, this means that your horizontal asymptote is the x-axis. Case 3 and 4 are very similar to each other, so be careful between getting these two confused. Case 3 says if the degree in the numerator is more than, and when it is more than, it has to be 2 or more, then the degree in the denominator, then there is not a horizontal or oblique asymptote. So here my n is 6, my m is 3, 6 is greater than 3, and it's greater than 3 by more than 2, so there is no horizontal asymptote. Now case 4, like I just said, is very similar to case 3. This one is if the degree in the numerator is exactly 1 more than, just more than the denominator, then we have to use long division, okay? or synthetic, and I don't know if I spelled that right, but or synthetic division, okay, if it's appropriate, to find the linear oblique asymptote. So we're going to do both here. So here, my n is 2. This is the same as x to the first, which makes my m 1. So because this is exactly 1 more than, then we have an oblique asymptote. So let's do this first by long division. I would have x minus 2. It does not skip any place, so I can just write this in. And now let's divide. So we would have 2x squared divided by x, which gives me 2x. Distribute that back. So 2x times x gives me 2x squared. 2x times a negative 2 gives me a negative 4x. We're going to subtract that whole thing. And I'm going to be left with 0 here. And then negative 3x minus a negative 4x is the same as plus 4x. So this is x. And we'll bring down our 4. And then we'll divide again. So x divided by x is 1. And I can stop right there. I don't care about multiplying this back and getting a remainder. This is my vertical or my oblique asymptote. Okay, let's see what this looks like when we use synthetic. Remember, you can only use synthetic if it's x plus or minus a number. And this one is the case. So let's use synthetic here. And when it is in this form, we're going to use synthetic. But I wanted to do this one by long division as a little bit of a review because they're not all going to be in the right form to use synthetic. So if I was to use synthetic, x minus 2 means that x equals 2. And then I would put my coefficient, so 2, negative 3, 4. We bring down our first one and then multiply, add, multiply, add. So I multiply to get 4, I add to get 1, and I really can stop here, but this is so easy. Multiply and then add, but this is my remainder and I don't care about it. So this is my constant and my x. We get y equals 2x plus 1. Okay, so we get the same answer no matter what. And so when I am graphing this, this goes all the way back to our first lessons in this class, literally the first lesson. My y-intercept, and then this tells me my slope, which is the same as 2 over 1. So I'll start at my y-intercept of 1, and then I will rise over run. I will rise 1, 2, run 1. Rise 1, 2, run 1. And of course, we can go in the opposite direction and go down 1, 2, and run a negative 1. So here is my oblique asymptote of 2x plus 1. If I go back to what I was talking about in the last video, remember this is going over 2 lessons here. Lesson 1 is basic, lesson 2 is advanced. Your advanced has holes and slant or oblique asymptotes. So in your basic, you will not have any slant, you will not have any holes. But when you get to advanced, you're going to have some holes and you're going to have oblique asymptotes. So let's go over to the next page, and these notes didn't work out super well how they usually do. So you need to flip the page and we'll do some examples. on this. And I can keep this kind of out here. Okay, but you can't really look at both at the same time. So example 3 has 8 examples, and we're going to find all horizontal or oblique asymptotes. You can only have at most one, and you either have horizontal or oblique. So you won't have multiple horizontal, you won't have multiple oblique asymptotes, you won't have one horizontal and one oblique. You either have one horizontal, you have one oblique, or you have none of them. So what I care about here is comparing my numerator to my denominator. Here, r of x equals 2x plus 7 over x minus 3. Okay, here, my numerator is 1. That's a 2x to the first. My m is also 1 because that's x to the first. So when my n and m are equal, this right here is case number 1. Now, if you don't need to write any of this, don't write any of that. But if this is going to be something helpful for you to look back on, write those down. When we have case 1 and my numerator degree is equal to my denominator degree, the horizontal asymptote is the ratio of the leading coefficients. So I have 2, this is a 1 down here. So I have 2 over 1, so that means my horizontal asymptote is at y equals 2. Because I'm doing 2 over 1. B, we have x to the 7th over x cubed. So here my n is 7. And my m is 3. So they're not equal. This one is when the numerator is less than, the numerator is more, so that's not it. So be careful between these two. When the degree of the numerator is more than and at least 2 more than, we get case 3, and this is our case. And case 3 says when the numerator is more than 2 than the degree of the denominator, then there is not a horizontal or oblique asymptote. So we have no horizontal asymptote or oblique asymptote. On C, we have 1 over x minus 5. This is the same as x to the 0 power. So my n is 0. We have no x's up there. My m is that's x to the first, so my m is 1. So this one is a case number 2. Because my numerator is less than the degree of my denominator. When that happens, my horizontal asymptote is simply and always y equals 0. Okay, x squared over x squared plus 1, n is 2, m is 2. This is a case when they are equal. So case 1. And case 1 says the horizontal asymptote is the ratio of the leading coefficients. Well, this is 1x squared over 1x squared. So 1 over 1 leaves my horizontal asymptote at y equals 1. On E, my n is 4. My m is 3. So my degrees aren't equal. My numerator is not less than. So case 3 says it's more than 2 than the degree in the numerator. Well, it's not more than 2, it's exactly 1 more. So we have to either use long division or synthetic. Well, this is not in the right form to use synthetic, so we need to use long division here. Okay, so we have x cubed minus x squared plus 1. Put in some zeros here because it skipped some places. We have 3x to the 4th plus 0x cubed minus x squared. And I have nothing left, but let's keep putting those placeholders just so everything lines up and is organized. Plus 0x plus 0. Okay, so we will go 3. Let me give myself some more room here. 3x to the 4th divided by x cubed leaves me with 3x. So it's going to go right here above my x and now distribute. 3x times x cubed gives me 3x to the 4th. 3x times a negative x squared leaves me with negative 3x cubed. 3x times 1 gives me 3x, and so I'm going to put that under my x, not my x squared. We're going to subtract this whole thing. That cancels. 0 minus a negative 3 is the same as 0 plus 3, so this is 3x cubed. Bring this down, negative x squared. And then 0 minus 3x is a negative 3x. And we don't really need to, but we can bring that down. So let's divide again. 3x cubed divided by x cubed. And that leaves me with 3. So I'll put that up there. Now again, we can distribute that back and get our remainder, but I don't care about that. I care about this top portion here. So this is y equals 3x plus 3. So that would have a y-intercept of 3, and then you would use your 3, which is 3 over 1, to go rise over run. Okay, F, I'm going to change colors for this, since this one went way too far over under my F. For F, my N is 4. My M is 1, because this is x to the 1st. So this is going to be a case 3. My numerator is more than 2 than the degree of my denominator, which means I have no horizontal or oblique asymptotes. So this is a case number 3, and we have no horizontal asymptotes or oblique asymptotes. And hopefully you can read that because my pen ran out of ink. Okay, on G, my N is 5, my M is 7. So this is a case 2 where my numerator is less than the degree of my denominator, which makes my horizontal asymptote equal y equals 0. And then lastly, we have N equals 2, M equals 1, so that's x to the 1st. So my numerator is not equal to my denominator. My numerator is not less than my denominator. So we have case 3 and 4. My numerator is not more than 2 than the denominator. It's only 1. It's exactly 1, which means we have a case 4 again. which we never wrote case 4 over here. So let's write that in so we can look back at that later and know. And when we have a case 4, we get an oblique asymptote. And to figure that out or to find it, we use long division or synthetic. Again, on this one, we had to use long division because it wasn't in the form to use synthetic. But this one very much is. And if it is, I'm using that. So x plus 3 means I have a 0 at -3. Put in your coefficients, and don't forget it's skipping a placeholder here, so you need a 0. So this is 3, 0, -12. We'll bring down our first one, multiply, add, multiply, add. This becomes -9. Add to get -9, and we can stop here, and I'm going to stop here. This is my constant. This is my x. So I have y equals 3x minus 9. Okay, here we would get our remainder, but I don't care what that remainder is. All right, that's how you find some horizontal asymptotes.